In this video, we are going to cover Avogadro's law, which is the last of the gas laws until we get to the big one. So what Avogadro's law says is the amount of gas represented with an N is directly proportional to the volume V when the temperature and pressure are held constant. So N is really going to be moles of gas initially. N2 will be moles of gas after a change. And then V1 will be your initial volume, and V2 will be your final volume. So looking at Avogadro's law, right as the amount of moles of gas present increases, the volume will also increase. This only is going to happen if you have a container that is expandable. So if I have an expandable container here and I pump 6 moles of gas into this container, this is the size the container would be. If I were to pump more gas into the container, now I've doubled the amount. I have 12 moles of gas in it. The expandable container is going to take up more space. It's going to expand. The volume is going to get larger because I have pushed more stuff into it. I pushed more gas particles in, which causes the volume to increase. The most obvious application of Avogadro's law is literally just blowing up a balloon. A balloon is an expandable container, and you blow gas particles into the container. And as you blow more and more gas particles in, the volume of that balloon is going to increase and the balloon gets bigger. And likewise, if we have a blown up balloon and we were to allow gas particles out, the container or the balloon is going to get smaller because it now doesn't house as many gas particles as it did before. Okay, cool. So let's do an example. We have 5 liters of a gas known to contain 0.965 moles. If the amount of gas is increased to 1.80 moles, what new volume will result, assuming we have an unchanged temperature and pressure? So let's first highlight the known variables that we are given, and let's pull them out. So the 5 liters is our initial volume. The 0.965 moles is our initial moles. The 1.80 moles is our final mole number, and our unknown is our final volume once we've changed the moles of gas. I can just plug these numbers directly into our equation, which is N1 over V1 equals N2 over V2. When I plug those numbers into the equation, this is what it looks like. And if you cross multiply and divide, so it'd be 5 liters times 1.8 moles divided by 0.965, your final volume would be 9.33 liters. To double check that this makes sense, we are increasing the amount of moles of gas. We're basically almost doubling it, which means that my volume should also increase, almost doubling it. So going from 5 liters to 9.33 liters checks out. We could also plug this number back into V2, solve for both sides of the equation individually. They should come out to the same thing, which they do. Sig fig wise, remember, since we are multiplying and dividing, when we cross multiply and divide, shockingly, we are looking at total sig figs. So we have 3 total sig figs here, 3 total here, 3 total here. So we should have 3 total in our answer. For example number 2, this one's a little more complex. We have a cylinder with a movable piston. So that's just a movable lid basically. Contains 2 grams of helium at 25 degrees Celsius. More helium was added to the cylinder, and the volume was adjusted so that the gas pressure remained the same. How many grams of helium were added to the cylinder if the volume was changed from 2 liters to 2.7 liters, assuming the temperature was held constant? So let's start by highlighting the known variables. So we know that we have 2 grams of gas. So that means that we need to convert that into moles at some point because we don't plug grams into Avogadro's law. We know our initial volume is 2 liters and our final volume is 2.70 liters. For an unknown, we are trying to solve for N2, which is our final moles of gas. However, we need to eventually convert that into grams because we're asked about grams. So we need to start by converting the 2 grams of helium into moles using compound stoich. I'm going to start with the 2 grams of helium in the upper left-hand box. We're going to bring grams of helium diagonal down. Based on the periodic table, it tells me that there's 4 grams per 1 mole of helium. So my grams will cancel out. I'll be left with moles of helium. So when we do 2 times 1 divided by 4, that gives me 0.5 moles of helium, rounding to the same number of sig figs as my starting answer, which is why I have these extra 2 zeros here. So that's going to go in for N1. So I've just changed N1 here, and we can now plug all of these known values into our Avogadro law equation, which should look something like this. And to solve for N2, we can cross multiply and divide. So doing 0.500 times 2.70 would be equal to 2.00 times N2. So you do 0.5 times 2.7 divided by 2, and you should get a mole value of 0.675. Rounded to proper sig figs, we have 3 sig figs here, 3 here, 3 here, so I rounded the answer to 3 as well. However, that's not my answer to the question because I was asked how many grams of helium were added. This is how many moles, first off, of helium I have at the end. I need to know how many grams were added, which means I'm going to take my N2, plug it back into stoich, go the opposite way here, 0.675 moles of helium, bring moles of helium diagonal down, molar mass up top, and we're going to multiply 0.675 by 4 to get 2.70 grams of helium as my final mass in my container. So to find how many grams of helium were added, we need to take how many grams I ended up with, minus how many grams I started with, which is the 2 from the problem. And I can tell you that 0.70 grams of helium were added to my container. Sig fig wise, because we're subtracting, we look after the decimal. So I have 2 sig figs after the decimal here, 2 after the decimal here, which is why I rounded it to 0.70. For this first check for understanding problem, hit pause, try and solve it on your own, and then hit play when you're ready. So for this one, you should have found your knowns to be 4.60 liters for V1, 0.225 moles for your N1, and 3.60 liters for your V2. And you should have solved for N2. This one was very straightforward. You could just plug it into Avogadro's law equation, look something like this, and when you cross multiply and divide, so it's 0.225 times 3.6 divided by 4.6, you should have gotten an N2 value of 0.176 moles, rounded to 3 sig figs because all of the numbers given had 3 sig figs. For check for understanding number 2, hit pause, see if you can solve it, and then hit play when you're ready. So this one was a little more complex. You should have pulled out your known values of 5.120 liters for V1. Your N1 is 8.5 grams that you should have converted to moles at some point. And your V2 is 18.10 liters, and you are solving for N2, which eventually you should have converted into grams. First step was to convert the 8.500 grams of chlorine gas into moles. So you should have divided by 71 grams, knowing chlorine gas is diatomic, so it's Cl2. And you should have rounded your mole value to 4 sig figs because that's how many are in your starting value. You should have gotten 0.1197 moles of chlorine gas as N1. I just updated it here. Once you had that, you can plug it directly into Avogadro's law equation, which should look something like this. And you should have cross-multiplied and divided to get an N2 value of 0.4232 moles. So again, that would be 0.1197 times 18.10 divided by 5.120, and this is what you would get to 4 sig figs because each of your numbers has 4 sig figs. However, that's not your answer because, again, you were asked to calculate the mass of gas added to the container. This is your final moles of gas in your container. So you had to convert your N2 back into grams using compound stoich. So taking that N2 value, multiplying by 71 grams per mole, should have come out to 30.05 grams of chlorine gas in your final container. And then you had to subtract from that number, since this is your final mass, your initial mass from the problem, the 8.5 grams, to figure out how much gas was added, which should come out to be 21.55 grams, rounding to 2 sig figs after the decimal because you have 2 here and 3 here, which means you need to round your answer to 2. So that is it for Avogadro's law.